Welcome students. Today we are going to discuss the amazing facts about the Avogadro's number. The numbers which we have discussed already in the mole, and these numbers are 6.022 multiplied by 10 raised to power 23 particles. Students, commonly these numbers are referred to the Amado Avogadro, who was the professor of the physics in the Italy University. But it is very interesting that these number was first used by another French physicist, and his name was Jean B. Perrin. Jean B. Perrin studied the Brownian motions of the molecules, and you know that Brownian motion is referred to the random motions of the liquid molecules or the gaseous molecules. Students, he calculated these numbers, saying that when we will divide the charge of the mole by the charge of the single electron, then you will get the numbers nowadays termed as the Avogadro's numbers, and these numbers calculated by the J. Perrin was 6.022 multiplied by 10 raised to power 23, and more commonly these whole numbers are 6.0221415 multiplied by 10 raised to power 23. Student, one thing I have told you that there are so much amazing hidden facts among these Avogadro's number, and these facts are related to that person who was not a scientist. Amado Avogadro was not a scientist, and it is amazing and it is astonishing that the Mr. Amado Avogadro was basically liar. He was very interested in the mathematics and physics. Due to interest in his physics, he became the professor of physics in the Italy University. He was very famous by his famous hypothesis about the gaseous volume. The equal volume of all the gases at the same temperature and the pressure will contain the same number of the atoms, the molecules. Students, on the base of that hypothesis, another term, the number of the particles per mole, which I have told you in my previous lecture of the mole, that 6.022 multiplied by 10 raised to power 23. These numbers resolves the issue of the unit of the counting of the mole. Now we will focus on these Avogadro's numbers and how we will calculate these numbers. If one of the value is to be known, the second values will be calculated. Students, as I told you that the Amado Avogadro stated as the Avogadro's number as the number of units in 1 mole of any substance defined as its molecular weight in grams equal to 6.022 multiplied by 10 raised to power 23. The unit may be, now we are going to explain the number of units in 1 mole of any substance, that these units may be electrons, atoms, ions, or the molecules. Focus that depending upon the nature of the substance and the character of the reaction. That is first time I am going to explain it. The nature of the substance and the character of the reaction, as that Avogadro's numbers, these numbers 6.022 multiplied by 10 raised to power 23 were named by the name of its own founder, that is Avogadro's. Hence, we called these numbers as a Avogadro's numbers. So, generally, in our context, for the convenience, we define it more precisely, these Avogadro's number as, these are the Avogadro's number are the number of the atoms, number of the molecules, number of the ions in 1 gram of atom of an element, 1 gram molecule of a compound, and the 1 gram ion of an ionic compound respectively. And these are the 6.022 multiplied by 10 raised to power 23. And these are the Avogadro's number. Now we will explain these Avogadro's number with reference to the 1 gram atom, with reference to the 1 gram molecule, and with reference to the 1 gram ion of the ionic compound. Students, as I have explained the definition of the Avogadro's number, now we will explain it with reference to the gram atom, gram molecule, and gram ion. One by one. First we going to discuss the gram atom of an element. We know that the atomic mass of hydrogen is 1.008, means 1.008 gram of the hydrogen is equal to the 1 mole, and that 1 mole of the hydrogen is equal to 6.00022 multiplied by 10 raised to power 23 atoms of the hydrogen. So these are the Avogadro's number of the hydrogen in the gram atom of the hydrogen. Similarly, the 23 grams of the sodium is equal to the 1 mole, and that 1 mole of the sodium contains the 6.022 multiplied by 10 raised to power 23 atoms of the sodium. Similarly, 238 grams of the uranium is equal to the 1 mole, and that 1 mole of the uranium contains the 6.022 multiplied by 10 raised to power 23 atoms of the uranium. Now students, you are better know that we have taken the examples of the least atomic weight of an element to the highest weight of an element, and that least atomic weight of the atom is the 1.008 gram of the hydrogen, and the highest weight of the uranium, that is 238 grams. Now you know that it is very interesting that either smaller mass, either larger mass, but we can also say that the different masses of the different atoms have the equal number of the Avogadro's number. These are the 6.022 multiplied by 10 raised to power 23. Now we can also explain it in other term, that as sodium is 23 times heavier than hydrogen, then hydrogen. So, for the equal number of the atoms in the 1 gram atom of the hydrogen and the sodium will contains the 6.022 multiplied by 10 raised to power 23 atoms. Means 23 times we will take the equal weight to get the equal number of the Avogadro's number for the hydrogen and for the sodium. As the sodium is 23 times greater than the hydrogen, we will have to take the 23 times more weight to the as compared to the hydrogen to get the equal number of the atoms. Another example, we will clear it as the magnesium is twice heavier than carbon, because the atomic mass of the magnesium is 24 and for the carbon it is the 12. It is the twice time heavier than the carbon. So for the convenience we can say that 10 gram of magnesium and 5 grams of carbon will have same number of atoms. As more conveniently I say that uranium which has the mass of the 238 grams and the hydrogen 1.008 grams, due to that hell of difference between the masses, different masses, but all these atoms have the same number of the Avogadro's number. Another example, for the gram molecule, we will take the different examples. Students, like atoms, that the different atoms have the different masses, but they have the equal number of the Avogadro's number, and these numbers are 6.022 multiplied by 10 raised to power 23. Same is true for the molecules, for the compounds, the number of molecules in the compounds, that the different masses of the different compounds will contain the same number of the Avogadro's number, and these numbers are 6.022 multiplied by 10 raised to power 23. We take the different examples of the molecules, compounds, and these are the first 8: water, glucose and sucrose. These are the different molecules. They have the different masses. As we know that the water contains the 18 grams, glucose has the 180 grams, and the sucrose has the 342 grams in the 1 mole. So the 1 mole of the water will contain the 6.022 multiplied by 10 raised to power 23 molecules of the water, and that gram molecule of the water is the 18 gram, and that for the glucose, the 180 gram of the glucose is equal to the 1 mole, and that 1 mole will contain the same number, same Avogadro's number, and these numbers are 6.022 multiplied by 10 raised to power 23 molecules of the glucose. And similarly, 342 grams of the sucrose, which is much heavier as compared to the mass of water, as compared to the mass of the glucose, that is the 342 grams of the sucrose is equal to the 1 mole, and that 1 mole will also contain the same number of the molecules as the Avogadro's number of the molecules. So we can say that the different masses of the different compounds will not affect the number of the molecules, and these molecules are always same, and these same number of the molecules are Avogadro's number of the molecules. Similar is the case for the ions, for the substances. We can take the different examples of the different ions which have the different masses, which have their different masses. So least mass, heavier mass, intermediate mass, but we will have experimentally proved that these ions have the same number of the Avogadro's number. Let's suppose we take the example of the sulfate ions. That mass is the 96 grams, and that 96 gram is equal to the 1 mole of the sulfate ion, and that will contain the 6.022 multiplied by 10 raised to power 23 number of the ions of the sulfate. And similarly, the 62 grams of the nitrate ion is equal to the 1 mole, and that 1 mole will contain the equal number of the Avogadro's number, and these are the 6.022 multiplied by 10 raised to power 23 ions of the nitrate. As we know that there is a hell of difference between the mass of the sulfate ion and the nitrate ion. So, but they contain the equal number of the Avogadro's number. So consequently, we can say that these Avogadro's number then designated and can be represented by the Na. For the convenience, that Na is very applicable to explain the various relationship, to find the number of the atoms in an element, to count the number of the molecules in a compound, to count the number of the ions in a substance. And what are these relationships? We will explain it. We are going to explain it. These relationships, that how we will count the number of the different atoms in an element, different elements. Students, as I have mentioned that for convenience, that Avogadro's numbers are denoted by or represented by the Na, and that Na is very useful for calculating the number of atoms, the number of molecules, the number of ions in a substance, in a compound, in an element. So we can say that relationship will be very fruitful for your anti-test. You can calculate the number of atoms, you can calculate the number of the molecules in the compound if you have the known amount of the compound in the term of masses. If you will have the masses of the different substances, different ions, different ionic compounds, different elements, then you can calculate easily their number of atoms, their number of molecules, and their number of the ions by using that relationship. And that relationship is, for the convenient, the number of the atoms will be equal to the mass of the element multiplied by the Na. Na means the Avogadro's number divided by the atomic mass. Similarly, the number of the molecules can be calculated by that relationship, and that relationship is equal to the mass of a compound multiplied by the Na, that is Avogadro's number, divided by the molecular mass. And the number of ions, by that relationship we can find the number of the ions by giving the values in that equation, that the mass of the ions multiplied by the Na divided by the ionic mass. So students, you don't worry about your anti-test. You can calculate. Such kind of the questions are also asked in your anti-test, in which you have to calculate the number of the atoms, number of the compounds, number of the ions in the various amounts of the element, in the various amount of the different compounds, in the ions, in the substance, in the ionic compounds. You can also calculate the number of ions, number of positive ions, number of the masses of the ions by using that relationship. And for the convenient, I also go ahead for that given relationship, the how you will find the number of positive ions, number of the negative ions, the mass of the positive ions, the mass of the negative ions, and overall species, the overall ionic compound, the whole of the compound, the whole of the element. That is very easy. Don't worry, I am going to explain it. Students, as I have mentioned, that don't worry, we have a technique to calculate the number of molecules, the number of atoms in the known amount of the compound, substance, by the relationship of the Na and these Avogadro's numbers. So we have the common examples that if we know that the 18 grams of the water is equal to the 1 mole, and that 1 mole of water contains the 6.022 multiplied by 10 raised to power 23 number of molecules of the water in that 18 grams of the water. If we will bifurcate it, if we will divide it, we know the formulae of the water and the known amount of this compound. Then we know that water is form of hydrogen and oxygen by the ratio of 2:1. 2:1. The 2 ratio of the hydrogen and the 1 ratio by the oxygen. So by that bifurcation we find that because 2 atoms of the hydrogen are involved in the formation of the water molecule, so the number of the hydrogen atom in the water molecule will be 2 multiplied by the Avogadro's number. That will be the atoms of the hydrogen in the water molecule. And similarly, because the ratio for the oxygen in the water is 1, so 1 oxygen atom is involved in the formation of the water. For the oxygen atom, we have the value of the Avogadro's number, that is the 6.022 multiplied by 10 raised to power 23 oxygen atoms in that water molecule. For convenient, we take another example, similarly of the 96 gram of the sulfuric acid, that is the molar mass of that sulfuric acid. And if we know that in that formula unit, the ratio of the different atoms involved in the formation of the sulfuric acid is that 2:1:4. 2 for the hydrogen, 1 for sulfur, and 4 for the oxygen. 4 oxygen atom, 1 sulfur atom, and 2 hydrogen atoms involved in the formation of the sulfuric acid. So by their calculating the numbers, what will be the number of the hydrogen, what will be the number of the sulfur, what will be the number of the oxygen in that formula unit of the sulfuric acid, that will be, because the ratio for the hydrogen is 2, that it will be the twice Avogadro's number of the hydrogen. So we will multiply the Avogadro's number by the 2. And similarly, for oxygen atom, the 4 times Avogadro's number of the oxygen, and we will multiply it 4 by the Avogadro's number. And similarly for the sulfur, 1 Avogadro's number of the sulfur are present, that is the 6.022 multiplied by 10 raised to power 23 atoms. The students, that is the simplest way to take the number of the atoms by their ratio in any compound, in any substance, in any formula unit. Now we also have another thing, that there are some compounds which ionize in their respective ions after dissolving them in their solvents. Let's suppose we consider the same example of the sulfuric acid, and we will dissolve it in the sufficient amount of the water, and it will get ionized into the different ions. The ions, hydrogen ions and the sulfate ions. Now how we will find the number of the ions, the number of positive ions, the number of negative ions in that formula unit of the sulfuric acid? What will be the mass of the positive ions? What will be the mass of the negative ion? It can be easily calculated. It can be easily found. And that easy way you will apply it on your anti-test exam and you will get the readily the answer of your question and you will get the maximum marks. Students, as I already mentioned that we can calculate the number of atoms from an element, or we have the known amount of that element that in terms of the masses, and we can also find the number of molecules from the known amount of that compound, and we can also calculate the number of the positive ions, negative ions, their masses in an ionic compound which is dissolved in a suitable solvent. Students, for the convenience for the ionization of that compound, for calculation of the positive or the negative ions in that ionic compound is sulfuric acid. Student, we dissolve it in the sufficient amount of the water and that sulfuric acid get dissolved and ionized into their respective ions, and these ions are, you know, that the hydrogen ions and the sulfate ions. Now students, we will have the different categories for the separation of the sulfuric acid into the ions. First we will take the number of the moles of that ion in that compound, in that substance, that the hydrogen ions and that is the sulfate ions. So we say that when we dissolve the 9.8 gram of the sulfuric acid in the sufficient amount of the water, then it will give us the 0.1 molar solution of the sulfuric acid. That solution will be termed as the 0.1 molar. Now that 0.1 molar solution, when bifurcated into the different categories, then we will get that solution after dissolution in the water will give the 0.2 mole or 0.2 multiplied by 10 raised to power 23 of the hydrogen ions. 0.2 mole of the hydrogen ions. These 2 mole, 0.2 moles of the hydrogen ions, and these will be multiplied by the Avogadro's number, and when after the multiplication that figure will give us the number of the hydrogen ions in the 0.1 mole of the sulfuric acid. Similarly, it will give the 0.1 mole or number of the sulfate ions, because it is bifurcated into the hydrogen ions, and these hydrogen ions are 2, and these are the sulfate ions, that the number of the ions of the sulfate is the 1. Our principal amount is of sulfuric acid is 9.8 grams, and that 9.8 gram is termed in the mole, then it will be 0.1 mole of the sulfuric acid. As I have mentioned, that substances when get ionized, we can calculate the number of positive charges, the number of negative ion charges, the number of positive ions, the number of negative ions, their masses, the mass of the positive ions, the mass of the negative ions. By that calculation, by the using the Na, Avogadro's number. So as I have calculated, when that sulfuric acid get dissolved, it will be bifurcated, it will be separated into its respective ions, that is the hydrogen ion and the sulfate ions. And I have already mentioned it. Now we are going to calculate the total number of the positive charges, and these positive charges will be, because the number of the moles of that positive ion is 0.2 mole, and that 0.2 mole will be multiplied by the Avogadro's number to get the total number of the positive charges. And similarly, for the negative charges, we will multiply the number of the moles of the sulfate ions to the Avogadro's number, to the value of Na. Now you will feel that here I mentioned the 0.1 mole, because 1 mole of that negative ion is formed. So that 1.1 mole is multiplied by the Avogadro's number to get the number of the negative ions. Now to get the number of negative charges, we will multiply it by the 0.2, because the sulfate ion has the 2 negative charges. Because it has the 2 negative charges, so we will multiply it by the 0.2 to the value of Na to find the total number of the negative charges, not negative ions. So later we can calculate mass of the positive ion and the mass of the negative ions. For that we will have again the 0.2, the total mass of the total value of the hydrogen ions, that is 0.2 mole, multiplied by the atomic mass of the hydrogen, that is 0.2 multiplied by 1.008 grams. That will give the total mass of the hydrogen ion. And after calculating the mass of the sulfate ion, we will multiply it by the 0.1 multiplied by the 96 gram ionic mass of that ion. And now here you see that I have multiplied it by the 0.2. Now here I have multiplied it 0.1. Why? The reason is that here we are going to find the ionic mass of the sulfate ion. Here we are going to calculate the number of the negative charges on the sulfate ion. So for the mass, we will multiply it with the ionic mass to the molar mass of the ion. So that mass is the 0.1. And so we can get by that relationship the mass of the negative ions, and by that relationship we can get the mass of the positive ion, and that positive ion is the hydrogen ion in the sulfuric acid and the sulfate ion in the sulfuric acid. And that's all. If you, in spite of this, I think you have completely taken the idea of the Avogadro's number and their various calculations. But if you find any difficulty in that topic, you may ask, as in the previous practice, on our website by subscription, and we will inshallah give you the proper answer of your question. And thank you very much.